Hey everyone, we're going to take a look at numbers 8, 9, and 10 from section 5.5. They're basically very similar. We're going to calculate the derivative in each case. So let's look at number 8 first of all. We want the derivative with respect to x of the definite integral from 0 to x squared of the function t divided by t plus 2. The dt, right, is just telling us that the variable of integration is t. So that's not part of the function we're integrating. Now, we are not going to find the antiderivative of t over t plus 2. I am going to let capital F be the antiderivative of t over t plus 2, but I'm not going to actually find capital F, right? The derivative of capital F, therefore, is t divided by t plus 2. And now I can think of evaluating the integral here using the fundamental theorem of calculus part 1. Right? We evaluate the antiderivative of t over t plus 2, which I'm calling capital F, right? We evaluate capital F at the upper limit and at the lower limit, and we subtract, right? So there's the evaluation by the fundamental theorem of calculus part 1. Again, I don't need to find the rule for capital F because we're immediately going to take the derivative. Right, that's what we have here. Take the derivative with respect to x. So what's the derivative of capital F of x squared? Well, chain rule. Outer function is capital F, inner function x squared, derivative of the outer function, f prime. Evaluate the inner function times the derivative of the inner function, derivative of x squared is 2x. Capital F of 0 is, I don't know, some constant though. Don't know what it is, but it's a constant number. It's a real number. Derivative of any constant is 0. What is f prime of x squared? Well, f prime of t, right, we define to be this, so simply replace t with x squared. So I've got x squared over x squared plus 2 times the quantity 2x. 2x times x squared is 2x cubed divided by x squared plus 2. And there's the answer for the first one, for number 8. Now, alternatively, this is the section on the fundamental theorem of calculus part 2, right? We're talking about using fundamental theorem of calculus part 1, or FTC 1 is the way I like to use it. Alternatively, we could have done this number 8 very similar by thinking of this integral as an area accumulation function. Well, I'm actually going to look at the integral from 0 to x and define that to be a of x, right? Because of that, the derivative of a of x by the fundamental theorem of calculus is just what? X divided by x plus 2, right? That's the fundamental theorem of calculus part 2. If I take the derivative of this function between my fingers, right, since I'm integrating from a constant to just x, this function of t, the derivative is just f of x, right? Just simply replacing that because we're integrating, and then we're going to differentiate right back to the original function, essentially. Cancel each other out in a sense. The difference now between this and, this a of x and this is what? We're plugging what in for x? X is the input to this function, which becomes the upper limit. We're replacing x squared, right? So we're really taking the derivative of a of x squared, which is what? Chain rule, right? Derivative of the outer function a, evaluate the inner, times the derivative of the inner function. Capital A prime of x squared. We know a prime of x is this. Replace x with x squared. Very similar to what we had previously. So really the same thing, but essentially we're using the fundamental theorem of calculus part 2. Okay, really the same thing, just different, maybe slightly different way of thinking about it. I like to do it the way I did this one, so that's the way I'm going to do numbers 9 and 10. So let's look at number 9. We're going to take the derivative with respect to x of this integral from 1 to 3 divided by x of cosine cubed t. So again, I'm going to let capital F be the antiderivative of cosine cubed. Okay, we're not going to actually find the rule for capital F. We don't need it. So I'm going to say capital F prime is cosine cubed t, which is cosine of t cubed. And so what is the antiderivative of cosine cubed? It's capital F. So we're going to evaluate the antiderivative at the upper limit and then subtract the antiderivative, evaluate the lower limit. And then I'm going to take the derivative. Well, again, derivative of this first one, it is the chain rule, right? Outer function is capital F, inner function 3 divided by x. Derivative of the outer function, f prime, evaluate it 3 divided by x. Derivative of 3 divided by x is negative 3 divided by x squared. And if you don't remember that, I just have you recall that 3 divided by x is the same as 3 times x to the negative 1 power. So when I differentiate, negative 1 comes down, negative 3x, subtract 1 from negative 1, negative 2. So I get negative 3 divided by x squared. There's our derivative of that. F of 1 is a constant, so the derivative is 0. So just bringing this expression out in front, what is f prime of 3 divided by x? Replace t with 3 divided by x, and there we have the answer. This is probably the form Achieve would like right here. They like to put the input to the cosine again in parentheses, as you probably should in this case. You can also write it this way, right? Cosine of 3 divided by x cubed is cosine cubed 3 divided by x. So you can write it this way as well, but this was what I think you need to put into Achieve. Okay, last one is here. Kind of crazy because they've got a variable s instead of x this time. But we're integrating u to the fifth, right, from negative 2 to cosine of s. It's kind of weird. Cosine of s, you really need the parentheses around it this time. So again, I'm going to let the antiderivative of u to the fifth to be capital F. Now you actually know what the antiderivative of u to the fifth is. It's 1/6 u to the sixth, but we're not going to even bother with that. Because again, I'm going to simply evaluate to evaluate this definite integral before I take the derivative. I'm going to evaluate the upper limit, evaluate the antiderivative at the upper limit. So capital F is the antiderivative at the upper limit of cosine of s minus the antiderivative evaluated at the lower limit. Then I take the derivative with respect to s. So again, here's a chain rule. Outer function capital F, take the derivative of that, evaluate the inner function, times the derivative of the inner function. Derivative cosine of s is negative sine of s. This is a constant, derivative is 0. So plug in f prime of cosine of s, replace u with cosine of s. I'll bring this negative sign in front. So I have negative the quantity cosine of s to the fifth times sine of s. This is what probably want to put into Achieve. This is fine on a test for me. Okay, so hopefully this makes sense now. If you got questions, please let me know.